Hi, everyone. I'm Wenshu from UC Berkeley, and this is joint work with my colleague Carol, my advisor Mike, and also Nikhil from Cornell Tech. So the project here we are thinking about is the stereotyping problem in collaboratively filtered recommender system. So first of all, why we start with this problem is because there's really a lot of wide applications of recommender systems. And in particular, recommender systems mediate our access to online information, and they also play a crucial role in many online platforms. And among many of these applications, a majority of the approaches are focused on matrix factorization techniques. So matrix factorization and collaborative filtering techniques are commonly used in practice. So just to illustrate a few applications here, which include news recommendation, online advertising, or music recommendation. So given these wide applications of these systems, we really need to care about whether they are actually fair and diverse to different types of users. Yeah, so just to reiterate a little bit, recommender system play a very important role in online information and online platforms. And I will start with some basics of the collaborative filtering technique here. So in general, collaborative filtering technique basically is trying to capture user preferences and item characteristics based on the principle that similar people might like similar items. So as an toy example here, if two users, Bob and Alice, both enjoy item 1, and Alice also further enjoys item 2, then the algorithm will try to predict that Bob is also likely to enjoy item 2. And this could be generalized to many users and items. And there are also different user-based collaborative filtering, which matches similar users, or item-based collaborative filtering, which more based on similar item types. So, so our idea here is based on actually a simple intuition of what are the limitations of this collaborative filtering principle. So basically, if we consider about it, collaborative filtering also implicitly assumes that these negative preferences are also transitive. So on one side, if I have two users who are similar and they both enjoy item 1, and one of the user, Alice, also enjoy item 2, then the system will predict that Bob is likely to enjoy item 2 as well. But on the other side, if these two users are similar, but Alice dislikes item 2, then if we use a CF-based algorithm, the algorithm might learn that Bob is also unlikely to enjoy item 2 as well. So based on this transitive preferences prediction, this algorithm might limit some users' access to diverse preferences if these preferences are different from the majority of the users. So that is what we call here as a stereotyping problem. And the idea here is if a user prefers a set of items that are anti-correlated in the broader population, then these items are unlikely to be jointly recommended to this user, regardless of this user's true preferences and ratings. And in particular, this problem may especially affect cultural minority. If other users do not like their culture-specific items, these diverse preferences are hardly to be captured by this CF-based technique. And how do we formulate this formally? So we introduced a concept called joint accessibility. And it basically means that if we consider a set of items, can these set of items be jointly accessed by a user? And this is trying to capture a fundamental requirement for content diversity in recommender systems. The question we are asking here is a user able to access or be recommended any combination of top K items that they might like? And in particular, we really focus on the accessibility here, and we consider the user might have different diverse preferences over sets of items, and the algorithm shouldn't limit their ability to access these types of items if they like them. So as an overview of this work, we formally introduced the notion of joint accessibility, and also we study this joint accessibility under systems using a standard single vector representation. And based on these feature representation, we provide necessary and sufficient conditions for this joint accessibility to hold. And surprisingly, we found that actually many of the current feature representation doesn't really guarantee the joint accessibility here, and we provide an alternative modeling fix for it. And lastly, we experiment these conclusions on real and simulated data sets and demonstrate that the stereotyping problem can really happen with real data. And that's why we need to consider fixes for them in order to improve the joint accessibility of the content. So let me briefly introduce a little bit notation here. So the setting here we are considering is a top K recommendation. So in every round of recommendation, the algorithm will pick a prediction of top K items that the user might like. And also in a standard matrix factorization model, each item is associated with a unique feature vector, denoted as Vj here. And the user is also represented by a feature vector living in the same dimension. And the predicted rating is simply the inner product of these two feature vectors here. So more generally, this score or prediction will also include item or user bias, but we start with this most basic dot product prediction. So by joint accessibility, we really mean that consider a top K recommendation where this recommendation set is the top K items with the K highest ratings. A recommender system satisfies the joint accessibility if and only if for any set of K combinations, it is true that there exists a user vector where this set could be recommended. So basically, this notion is really trying to capture for any given user representation, is this set possible to be recommended or not? And also this is a really weak requirement here because we are just considering over the entire user representation space, can this set even be possible to be recommended together? And we further say that a given set S is jointly accessible if there exists a user vector such that this S is recommended. So what are some interpretation of this very abstract mathematical notion here? So the first geometric interpretation is actually pretty simple here. So on the right side, we are showing 4 items here, and they are living in a 2-dimensional feature space. So these are item 1 to 4. And we just consider top 2 recommendation. So the algorithm is trying to pick 2 items that are most likely to be liked by the user. And here we can see that if I consider the sum of the feature vector for every combination of 2 items, there is some problem with item 1 and 3 and item 2, 4, because they are really living in the opposite or like half space in this feature space, and the sum of their vector is very small because of the opposite directions. And actually, we can show that if the sum of the feature vectors of K items are not a vertex of this convex hull, then this set of items is not really accessible by any users. So in particular, in this example, the pair of items 1, 3 and the pair of item 2, 4 are not really accessible for any user feature vector. And given this first geometric interpretation, there is also another alternative way to think about the accessibility. So here, I'm again showing 4 items and with a normalized feature vector in this feature space. And if we consider the Voronoi diagram of these feature vectors, it turns out that the item is only accessible by the user vector if this user vector is inside the Voronoi cell of this item feature vector. And by a Voronoi cell, it really just means all the feature vectors which are closest to this item feature vector compared to the distance to other feature vectors. And why we can see the joint accessibility problem here, because if we look at item 1 and item 3, their Voronoi cell is not neighbors to each other. And in particular, mathematically, we can show that if the Voronoi cell of two item feature vector are not neighboring each other in this Voronoi diagram, these pair of items are not accessible, similar to the conclusion we have for the convex Hall interpretation. So I guess in these interpretations, we can sort of see guaranteeing the joint accessibility actually is pretty hard with the single feature vector representation. And in fact, we are able to show that individual accessibility, in fact, does not imply joint accessibility, in particular for the single vector feature representation. So given this impossibility result with the single vector user representation, the alternative fix we proposed in the paper is precisely to represent each user by different multi-vectors instead of just a simple single feature vector. So lastly, we demonstrate whether this fix can help improve the accessibility of the system and whether the single vector representation really have this accessibility issue with some synthetic and real data sets. So in the synthetic data set, I will quickly describe how we created it. Basically, we manually construct a group of users, which is around 20% of the entire user set to be the minority group, and the other 80% users to be the majority group. And what we do with this 20% minority users is to give them two preferences or two preferred topics, which are different from the majority user. So what we are really trying to do here is to construct a minority user set with different preferences compared to the majority users' preferences. And then we just compute the fraction of accessibility for pairs of items over all the pairs of items in this item set. And we indeed see that after training a standard matrix factorization recommendation algorithm, the trained single vector recommendations is far away from the oracle accessibility. And in particular, this is more prominent if the item pair vectors has a lower similarity score here. And also, if we have a closer look at the predictions, we can see that if we consider a majority preferences and a minority preference, and the items that are not accessible are exactly these combinations of one minority preference and one majority preference. So basically, these two columns and rows on the side are these pairs of items that are never basically recommended or seldom recommended to the users. Even the minority user precisely like these two topics, but they're not jointly recommended together. So
okay, yeah, time to wrap up.
Thanks. Yeah, so the main message here is we considered the stereotyping problem of CF-based recommender system. We introduced this notion of joint accessibility and also demonstrate that the current CF-based recommendations indeed appears to have a poor joint accessibility over item sets. And in terms of future work, we would be interested in new training algorithms with multi-vector representation and also other alternative representation models or recommendation heuristics. With that, I will conclude my talk, and thanks for listening.